On the heels of discussing the multiplication of binomials, let's look at the three special cases. These situations are of significance due to the fact that the College Board, which is the administrator of the SAT, likes to test our recognition of patterns. We will look at such an example of a real SAT problem later, but for now, let's analyze. Our first setup is multiplication of a binomial with an addition by itself, or squaring. As we discussed in the video on the multiplication of binomials, what we get is a times a, which is two first terms of both binomials, plus a times b, multiplying the first term of the first binomial by the second term of the second binomial, and then plus b times a, which is the second term of the first binomial by the first term of the second binomial, and plus b times b. As we know, a times a is a squared, then the middle part of plus a times b plus b times a, since the sequence of multiplication is irrelevant and a times b is the same as b times a, what we get is 2 times ab, or we could say 2 times ba. It doesn't change anything. And then we have the last part of b squared, which is the result of b times b. By now, some of you may have gotten confused with all the sounds of these letters. So let's step back a little and analyze. As we know, the letters represent two different numbers, and in this case, it can be anything. And this abstraction allows us to formulate something that we can apply to different situations. And if we are just patient enough, we can see how it all unfolds. And with the exception of the transition of a times b turning into ab, where the word times is dropped, everything else should make sense to you as we go along. If I asked you to square a plus b, there is a good chance that you wouldn't have anticipated the middle part of plus 2ab that we got at the end. It's quite reasonable for us intuitively to simply square both a and b, and as a result getting a squared plus b squared. However, you have to be careful and cognizant of this middle part, plus 2ab, moving forward, because this is a difference between getting a question right and getting a question wrong. Next, we will look at the second special case of multiplying binomials. In this case, we will take a binomial with a difference, so a minus b, and we'll square it. So squaring means multiplying by itself. So what we have to do is to multiply a minus b by itself. And using the same process that is discussed in a separate video on multiplication of binomials, and something that we did in a little bit more detail earlier in this video, what we get is a squared minus 2ab plus b squared. So the process is the same. The difference is the middle part, where unlike in the first situation where it was the addition of a times b twice in a slightly different look, in this case, we get a negative a times b minus b times a, and that results in the middle part of minus 2ab. And just like in the case with addition, this middle part of minus 2ab is again something that might be unexpected somewhat, but something that we need to keep in mind. And if, again, I asked you to tell me what you thought a minus b squared would be, a lot of times you may just go ahead and add a square to a and then add a square to b and offer as an answer a squared minus b squared. But the reality of it is that it is a squared plus b squared, but also with the middle part of minus 2ab. And this is something that we need to remember, again, to get those extra points on the SAT. Now let's look at the third and final special case that we will consider. It is the product of a sum and a difference. So it is the same terms of A and B, but in the first case they're added, and in the second binomial, B is subtracted from A. We use the same process, and unlike in the first couple of cases, here the middle part of A times B in a negative is neutralized by the addition of B times A. And what we get as a result is A squared minus B squared. I would be the first one to argue that this is way too much information to carry around. So what I suggest is that you just remember that intuition is not your best friend when it gets to facing the binomials, and specifically multiplication of binomials. So do what works best for you, understand the process, and go into the test with confidence that even if you forget the formulas, you can still derive it on the spot and come up with whatever it is that you're looking for. But remembering the pattern will clearly give you an advantage.